Hey everyone, and welcome to another edition of The Explainer. Today we've got a fantastic one lined up for you. We're tackling Surds. Now I know, just hearing that word can send a shiver down the spine of, well, a lot of math students. But today, we're treating this as your ultimate level up GCSE study guide. By the end of this explainer, you're gonna master Surds, lock in those maximum marks, and honestly, you might actually find them kind of fun. Let's get into it. Okay, so here's our game plan. We'll start at level 1, what are surds? Then, level 2 is simplifying surds made easy. After that, level 3 covers adding and subtracting rules, followed by level 4 on multiplying and dividing. Then we hit the boss battle in level 5, rationalizing the denominator. And we'll wrap up with level 6, tips for maximum marks.
So, kicking things off with section 1, what are surds, the foundation? You might be wondering, why on earth do mathematicians insist on using these intimidating-looking symbols instead of just regular numbers? Well, a surd is an irrational number that we intentionally leave as a square root to give an exact value. Think about it. If you plug the square root of 3 into your calculator, you get 1.732050808, and it literally just keeps going forever. There's no recurring pattern. So instead of writing out infinitely messy decimals and losing accuracy because you had to round it off, surds are actually this brilliant shortcut. They let us maintain perfect, exact precision. It's exactly the same logic as using the pi symbol instead of writing 3.14159 over and over. Take a look at the difference here between a real surd and, well, a fake one. On the top, you've got real surds, right? Root 2, root 13, root 99. But look right below that. Root 16 is literally just an integer in disguise. Because 16 is a perfect square number, the square root of 16 is exactly 4. That is not a surd. So always be on the lookout for imposters when you're taking your exam.
All right, moving right along to section 2, simplifying surds made easy, also known as the golden rule.
So as we hit level 2, here is your absolute golden rule, your cheat code, if you will. Always look for the hidden square number. When you look at a surd like root 8, you really want to ask yourself, hey, is there a square number hiding inside this as a factor? And yes, there is. 4 is a factor of 8. So root 8 is really just root 4 times root 2. And since the square root of 4 is exactly 2, we can just simplify this whole thing down to 2 root 2. Finding and pulling out that perfect square factor makes the whole problem smaller and vastly easier to work with.
Let's walk through this 3-step mechanic visually with a slightly tougher one. Say we need to simplify root 48. Step 1, scan your memory for square numbers that divide cleanly into 48. 16 works, because 16 times 3 is 48. Step 2, you just rewrite it as root 16 multiplied by root 3. And step 3, evaluate that square number. Root 16 just becomes exactly 4. So your final answer? 4 root 3. Trust me, getting into the habit of doing this simplifying mechanic first will save you from giant headaches later in the exam. Okay, leveling up again. Section 3, adding and subtracting rules, the algebra disguise. Now, I know this might look a bit scary at first glance, but I promise it's just standard algebra wearing a very clever disguise. Notice how the algebra column compares to the surds column here. If you have 3x plus 5x, you know instantly you have 8x, right? It's just basic algebra. Well, treat the root 3 exactly like you would treat the letter x. 3 root 3 plus 5 root 3 instantly becomes 8 root 3. It's a remarkably simple mental calculation once you see through that disguise. But, and this is a big but, there is a catch. Just like you can't add an x to a y and magically get a single term, you can only add surds together if the number under the square root is absolutely identical. For example, you can definitely add 3 root 5 and 7 root 5 to get 10 root 5. But you absolutely cannot add 3 root 5 to 5 root 3. They're totally different surds, we call them unlike surds, and you just have to leave them separated. Which brings us to a massive examiner trap. I mean, they love catching students out on this. Never, ever just add the numbers under the square roots together. Listen, root 9 plus root 4 does not equal root 13. No way. Let's prove it right now. Root 9 is exactly 3. Root 4 is exactly 2. So 3 plus 2 equals 5. But root 13, that's a messy, irrational decimal somewhere around 3.6. They are clearly not equal. Do not fall for this trap when you're sitting in the exam hall.
Moving on to section 4, multiplying and dividing surds, the separation technique.
Okay, welcome to level 4. Now, when multiplying and dividing, the rules actually change entirely. The absolutely crucial point here is that when you multiply, you have to keep your teams separated. Outside numbers multiply other outside numbers. Inside numbers, meaning the ones trapped under the square root, well, they multiply other inside numbers. And our pro tip from earlier definitely still stands. Always check if you can simplify a surd before you multiply. It keeps the numbers so much more manageable.
Let's see this separation technique in action. We've got 5 root 6 multiplied by 2 root 5. First, we take the outside numbers. 5 times 2 is 10. Simple enough. Then, we take the inside numbers. Root 6 times root 5 is root 30. Put them all together, and you get 10 root 30. Honestly, by just keeping the inside and outside teams strictly separated, this multiplication is an absolute breeze.
All right, take a deep breath. Section 5, Rationalizing the Denominator. The boss battle.
This is it, the final boss battle of the Gcse surd syllabus, removing the surd from the bottom of a fraction. But to defeat this boss, you need a secret weapon. And believe it or not, that weapon is the number 1. Wait, really? Yes, really. Rationalizing is actually just a neat trick where we manipulate the way a fraction looks without actually changing its true value. And mathematically speaking, you can multiply anything by 1 without changing its underlying value. We just have to use a very, very cleverly disguised number 1.
So here is exactly how it works. Let's say you have a fraction with root 5 on the bottom. Step 1, identify that denominator. Okay, it's root 5. Step 2, multiply both the top and the bottom of the fraction by root 5. Why? Because root 5 divided by root 5 is exactly 1. We aren't changing the fraction's actual value at all. And then step 3 is where the magic happens. When you multiply root 5 by itself on the bottom, the root effectively breaks, leaving you with a nice, clean, rational integer, 5. Boom, boss defeated. Now, I should warn you, sometimes this boss has a second phase, the complex denominator. If the bottom of your fraction is something tricky, like 1 plus root 3, well, multiplying by just root 3 isn't going to save you. You have to use the difference of 2 squares. You multiply the top and bottom by the exact same expression, but, and here's the kicker, you reverse the sign. So instead of plus, you multiply by 1 minus root 3. This is known as the conjugate. And doing this causes the middle surd terms to cancel out completely, leaving you with a beautifully clean integer denominator.
And finally, Section 6, Tips for Maximum Marks to Secure Your Grade.
Okay, you've officially defeated the mechanics of surds. Amazing job. Now, let's look at some insider info straight from the exam board to make sure you lock in those top grades. Listen to this. If your calculator gives you an answer as a surd midway through a question, do not press that S to D button to turn it into a decimal. Examiners actually reward you for keeping exact values. If you round it off too early, your final answer is going to be slightly off and you'll lose precious accuracy marks. So keep that surd alive until the very bitter end.
All right, here is a rapid-fire review of the most common pitfalls so you don't lose silly marks. Number 1. When simplifying, always try to find the largest square factor first. It literally saves you from having to do the whole process twice. Number 2. Never, ever combine unlike surds. Treat them like totally different letters in algebra. Number 3. If you're expanding double brackets with surds, double-check that you end up with 4 terms before you start simplifying. And number 4, when rationalizing denominators, always check if the regular integers in your final fraction can be simplified down, just like a normal fraction.
And there you have it. With these cheat codes in your back pocket, you are totally prepared to conquer surds in your exam. You know the foundation, you know the golden rules, and you've got the secret weapons. If this explainer helped you level up your maths game, please don't forget to hit that like button and subscribe to the explainer. It really helps us out and lets us bring you even more of these GCSE survival guides.
I want to leave you with just one final thought. The magic of surds is really just the magic of looking beneath the surface, isn't it? It's about finding that hidden square number that makes a complex, intimidating problem brilliantly simple. So as you go back to your studies today, I challenge you. Can you spot the simplicity hidden inside the complexity? Keep your eyes peeled for those perfect squares, and keep up the fantastic work. Thanks so much for learning with me today.